Welcome to the Introduction to Bash module, in which we'll do our first step in using Bash to manage IT infrastructure in Azure. So in this module, you'll learn what shells are and what Bash is. You'll learn about the syntax of Bash commands, about important Bash commands such as ls, cat, and ps. You'll learn how to use I/O operations to redirect input and output, how to update a server's operating system, how to find and terminate stalled processes, and how to use Bash to filter Azure CLI output. Now, as a reminder here, this module is part of the prerequisites for the AZ-104 for Azure Administrators certification. So let's get started. And we start with the Bash overview and the question, what is Bash? So the Bash shell serves as a fundamental tool for Linux system management and administration. The name Bash represents born-again shell, indicating its evolution from the original Bourne shell. When working with Linux systems, and in our case, Linux systems located in Azure, Bash functions as an interface between users and operating system. The system processes commands through this shell interface. These commands can be executed directly in the console or through scripts for automated operations. The service operates on three core Unix principles. Initially, programs focus on performing single tasks effectively. Following this, these programs can work together through a system of pipes and redirections. The system uses text streams as a universal interface, simplifying data flow between components. Now, Bash implements file-centric approach to system operations. The service treats all system elements as files, including hardware devices and network connections. This approach creates a consistent interface for input and output operations across different system resources. Now, for system administration tasks, Bash provides both built-in commands and the ability to execute external programs. These tools work together to provide comprehensive system control. The shell's scripting capabilities enable automation for complex administrative tasks. Next up, we'll be talking about Bash fundamental. In this lesson, we'll be talking about Bash command fundamentals. This lesson will be separated into several smaller parts, and we start with Bash command syntax. So, Bash command line interface operates through a straightforward yet powerful syntax structure. The service follows a consistent patterns for command execution, making it accessible for users at all skill levels. When working with Bash commands, three main components work together. The command itself, as you can see on my screenshot or on my presentation, then options or flags follow the command, and the arguments. The system processes these elements in a specific order, with the command always being the first string encounter. The command components serves as the primary instruction. For example, this ls command will instruct the system to list directory contents. This command will initiate all subsequent actions in the command sequence. Following the command, options modify how the command operates. These options start with the hyphen and can be combined for efficiency. For instance, ls-a will show all files including hidden ones, while ls-l will provide detailed information. These options can be combined as ls-la or ls-al to achieve both effects simultaneously. And then arguments. Arguments provide specific targets for commands. The system processes these arguments arguments based on the command and options specified. For example, ls/etc will target the etc directory specifically rather than the current working directory. So let's take a look at how we can use it in our Azure Shell environment. So let me run the command ls itself to reveal the contents of this current directory. As you can see, we've got some example files here I've pre-created for the demonstration purposes. And as you can see, we've got lots of image files, JPEG, PNG, JPEG, and so on, and one text file. So now let's add an argument to this command, because when we ran this command itself, ls, it revealed the contents of current working directory. And by the way, to check your current working directory, you use pwd command. As you can see, here is my current working directory. Now, if we want to list the contents of some other directory, we could add an argument like, for example, etc, /etc. And by the way, this / is the root of our file directory, file structure. So our file structure in Linux starts with the root. And to denote this root, we use /. So etc directory is located under the root directory. And if we run this command, that will list the contents of the etc directory. Now let's get back to our ls command rather than file system and try to run another command, ls-a. Now, as you can see, we've got much more files because now ls command reveals all hidden files. And by the way, all hidden files are starting with dot in Linux. So we've got .bash history, .bash logout, and so on. These all are the hidden files, and this option -a reveals all the files. This -a is an abbreviation for all. Now let's try to run ls-l command, and the output is completely different because now we instruct ls command with this option or flag to provide detailed information or long listing. This -l is an abbreviation for long listing. And let's try to combine these two options or flags. And by the way, let me clear the screen, and to clear the screen you'll press Ctrl+L or you type clear command. So let's run ls-la and let me make the font a bit smaller like this. So we get a long listing for all the files. Now we get these hidden files among all other files with all the additional information for this file. And by the way, we'll be talking about these elements and additional information for the file later on, what all these fields mean. Now, just remember that you can list just the contents of the directory with ls command, or you can list all the files, or you can list long listing for the files. And by the way, if you want to follow along, you could create the temporary demonstration files with touch command. So this touch command will create any file with the name you provide really fast. For example, what file we could create? Let's list. Let's say that we want to create a file like this, but with I instead of Esther. So I'll type touch file.txt. And now if I list the contents, we'll get one additional file .txt. And you could add any extension to the file. By the way, Linux doesn't really require to use extensions. These extensions in Linux are for your convenience, for you to better orient in Linux file system. So again, let me get back to the slide. In any Linux system, we've got such a command syntax. Command itself, first string bash encounters, then the options for the command, which modify command behavior, and the arguments for the command for the command parameter. Next up, we'll be talking about Linux help system. The Bash command line interface provides comprehensive built-in documentation tools. The service operates through two primary help systems, the man command and the -- help option. So, when learning Bash commands, the man command serves as the primary documentation source. The system displays detailed manual pages that explain command functionality or its options and usage example. For instance, typing man mkdir will provide complete documentation for the directory creation command. Let me switch to my local shell, and by the way, it's Z shell. It's a bit different from the bash which we use in Azure shell, but the core components are the same. There are some differences which you could encounter, but in its core components, all the shells are quite similar. So let's try typing man mkdir here, and we'll get a comprehensive detailed manual pages which explain this mkdir command. We get its name, what it does, it makes directories, then the synapses for this command, how you use it and how you type different arguments and options, then the description for this command. The options are as follows, and by the way, to scroll down you could press space here and go through all the pages of this manual. And when you want to exit, you just press Q to exit this manual. Now, another option you could use is, let me get back to our help slide. So it's -- help option. This -- help option offers a more concise approach to command documentation. This component provides quick access to essential command syntax and available options. The format presents information in a straightforward, easy-to-scan layout. Let's try running this -- help for our mkdir command. I'll type mkdir -- help. And by the way, it could give us an error because it's this shell. Yes. So illegal option, as you can see, that's one of the differences between bash and this shell. Let's try running this command in our Azure shell instead. And I'll get back to my Azure shell, clear the screen with Ctrl L and run the following mkdir -- help. Now, as you can see, we get a concise output to the command documentation. So we get this quick access to essential command syntax and available options, as for example this -p option. Please remember it. We'll be using it later on. It's quite a handy option. So depending on the details you want to get, you could use either man command to get the documentation or -- help, which offers concise command summary. Next up, we'll be talking about using wildcards in bash. It's quite important to understand how to use wildcards because it helps much to work with file system. I'll see you there. Linux provides powerful pattern matching capabilities through wildcards. Linux operates through several special characters that represent different pattern matching rules. So, for instance, this primary wildcard is the asterisk character. It serves as the most versatile wildcard. The system uses this symbol to match 0 or more characters in file system or file names. For example, the command ls**png will display all PNG files in the current directory. Let's take a look at these two examples in our Azure shell. And by the way, please note again to remind you, Linux doesn't formally recognize file extensions. They are just part of the file name. Okay, let me switch to Azure Shell to demonstrate the usage of wildcard. So let me list the contents of the directory we've got, and let's say that we want to find all files which start with the JPG extension. For this, I'll type ls wildcard for all the files and then .jpg. Okay, that found all the JPG files in our working directory, but what if we want to find also these JPEG files? For this, we'll use the following. The previous command, by the way, you go through the command lists in your history with up arrow and down arrow to find the needed command in your history. We'll be talking about working with history later on, but for now, just remember that to find a previous command, you press upper arrow. So let's find this previous command, ls**.gpg, and add a wildcard character here between P and G. We'll add an asterisk and hit enter. Now it finds all the files either JPG or JPEG, right? Now let's get back to our slide, and here it is, another slide, and we go to another wildcard, which is question mark. So the question mark provides more precise matching. This wildcard matches exactly one character, making it useful for files with consistent naming patterns. For example, if we've got lots of JPG files starting with 3 zeros and we want to match all of them, we want to match files like 301 through 309 for. Then we'll use this question mark wildcard. Let's run this command. I'll clear the screen, run ls command, and as you can see, we've got these files 001, 003, and so on. So let's type the following command. ls00 question mark .gpg. And that will find all three files starting with 30. See how handy can this wildcard be. Now, we can use square brackets to create character sets for matching. This square brackets wildcard matches any character within the brackets. It allows specific character matching. The system supports both individual characters and ranges within brackets. For example, this example, ls a-z in square bracket. It will match files starting with any lowercase letter. So again, let me get back to Azure Shell and run some examples here. So let's run the command which lists all the files in the current directory whose names contain a period immediately followed a lowercase g or p. It will list all the JPG or JPEG and PNG files, but not .gif files. For this, we'll write the following command: ls, then the asterisk wildcard for all the files, and then we'll specify what extension we want to find. We want to find in square brackets either extensions starting with J or an extension starting with P, right? And then any continuation of this starting. And for this, we'll use another wildcard character. I'll hit enter here, and that finds all the extensions except this one, .png, or this one, .gif, or this one, .jpg. Why is that? Because Linux is a case-sensitive system, and when you use lowercase, it treats the lowercase letters differently than uppercase letter. Now let's combine this previous search string, and let's say that we want to find all files including the files with uppercase extension and uppercase J and uppercase P extension. We'll hit enter here, and now it finds all the files including these two. Now, expressions in square brackets can represent ranges of characters. For example, if we type the following command, ls, let me clear the screen, and type ls square brackets, and we want to find all files starting with A through Z. So the files should start with lowercase a through Z and then follow any continuation. And we get all the files except the ones which start with 3 zeros, and except the ones which starts with uppercase letter. Now, to change this situation, we could type uppercase A and uppercase Z here, and that'll find only one file, file 5, which starts with uppercase F. Now, we can also combine this search string, and we can add A lowercase through Z lowercase, and then A uppercase through Z uppercase. That will find all the files within this range. Now, based on these examples, can you guess what the following commands will do? Let me type them for you. I'll command them. It means the system won't run these commands. This pounds means a command, and the system ignores it. So the command is as follows: ls in square brackets 0 through 9 asterisk. What will this command do? Then one more command. We'll add one more asterisk here, and we'll remove finally this asterisk. Could you guess what these commands do? That'll be as a small task for you to answer these three examples. Now, one more thing I'd like to mention here, and we finish this wildcard characters lesson, as well as Bash fundamentals lesson, and that is using escape characters for wildcards. So when working with file patterns in command line operations, special characters sometimes need special handling. The system provides the / character as an escape mechanism for this purpose. For situations when file names contain special characters like asterisk, the / serves as a prefix to indicate that the following character should be treated literally. So we don't want to use this character as a special character, but we want the system to treat it as an ordinary character. And in this situation, we'll use / which precedes any special character that needs to be matched exactly. Again, I'd like to remind you that don't try not to use special characters in your file names, but there are some cases when it is needed and you want to use and to find the files containing special characters in their names. Let's take a look at these three examples. In the first example, we're searching for the files containing asterisk in the middle of their name. So all files can start with any letters or symbols, and then they should contain asterisk in the middle of their name, and they can have any ending. Or, for example, we want to find all the files containing question mark in their name. Or, for example, we want to find any files containing square brackets in their name. Let's take a look at this example in Azure Shell. So let's list the contents, and I've got a file named like this, f*le.txt. So how will we find this file? For this we'll use ls, then we'll be searching for the files starting with any symbol. For this we'll use asterisk like this, and then we'll use / to find asterisk in the file name being treated as an ordinary symbol, like this. And then we'll be searching for any continuation of this file, and we'll use asterisk once more. That will find our file. Again, while searching for files with special characters is possible, it's important to note here that using special characters in file names is not recommended. The system allows for such searches primarily to help manage existing files with problematic names or to handle some cases in file management scenarios. But try not to name the files when you do. For instance, you could type touch to create a new file and then file ? .txt. Don't do this if it's possible. Don't use this question mark in your file name. While it's possible, if we list it, now we've got this file .txt file. And now to search for such a file, we'll use ls asterisk for all files. Then we use escape character for the question mark and then asterisk for any extension. That will search for the files with question mark. And we get an error, cannot access this. Let's try remove this asterisk again. So as you can see, we've got lots of troubles finding this file containing question mark in its name. And can you guess why? Because I've used / because of instead of backslash. So we'll be searching, we'll be using backslash to search for, to escape the special character. Again, I'll add an asterisk here and that will find the file. So that finishes our Bash fundamentals lesson. It contains 3 parts, as you remember. The first one on command syntax, the second part was on getting help in Linux, and then we've talked about using wildcards in Bash. Next up, we'll be talking about Bash commands and operators, and this lesson will also be separated into several smaller parts because it's quite informative, containing the commands from different sections such as file navigations command, file operations commands, file content command, and so on. So I'll see you there. The Bash shell provides essential commands for system administration and file management in Linux environments. Let's explore the key command categories and their functionalities. So we've got commands for file navigation, for file operations, file content commands, the commands for administrative operations, process management commands, and I/O operations operator commands, or I/O operations. Let's start with file navigation commands. So file navigation forms the foundation of Linux system operations. It's essential to know the commands how you can move around your Linux system. The Linux system provides several essential commands for effective directory and file management. And first command you need to know is ls command. It serves as the primary tool for viewing directory contents. When used without options, as you remember, ls displays basic file and directory names in the current location. So if I switch to the terminal and run ls command, that will reveal all the contents of the current directory I'm in. For comprehensive file information, the -l option or flag shows detailed attributes including permissions, ownership, size, and modification types. The service includes hidden files, those starting with a period, and when using the -a flag, we can reveal them. So let's try to run this ls-la, and that will reveal and show us totally different output. As you can see, we've got lots of files starting with dot here, hidden files, and we've got another output with detailed comprehensive information, including permissions, ownership, size, and modification time. The cd command facilitates directory movement throughout the system. The system recognizes several special notations. If we type cd followed by a directory name, it will move to that location. If we type cd ... it will move up one directory level. And if we type cd tilde, it will return to the user's home directory. And finally, cd without arguments also will return to home. So let's run these commands. Let me clear the screen, type ls. Let's say we want to move to this temp directory, right? So we'll type cd temp, but I won't be typing the whole directory name. I want to show you how to use tab here, tab completion. So if I hit tab here, that will auto-complete the command for me. Now I'll hit enter, and right now, as you can see, the directory is changed. And by the way, to check your current working directory, you could type pwd. That will reveal the directory you're currently in. Users, and again, I'd like to note here that uppercase U and lowercase u are treated differently in Linux. So current working directory is users, my username, and temp directory. If we type here cd ... now the directory is changed to users, my home, my username. Now let's go to this directory parallels. I'll type cd uppercase P, hit tab, and that will offer me the options because there are several different directories starting with uppercase P. So I'll need to add A here, hit tab again, and that will autocomplete now because this name is unique right now. And by the way, if I remove it and type lowercase p and then continue typing like this, hit enter, that will be a completely different directory. So if I ls here, that will contain my parallels virtual machines. So again, if I want to return to my user's home directory, I type whether cd without any arguments or cd tilde. That'll get me back to my user's home directory. As you can see, it's my user's home directory. Now, I've already mentioned several formats or formatting options for ls command. You already remember ls-l, which shows detailed file information, ls-a reveals hidden files and directories, and you can combine ls-la both for detailed view and hidden files. And there are also lots of different other options with ls command. And your brief task will be to find any useful options which you can remember. And one of them is, for example, ls-h. That will present file size in human readable format. Let's change our directory to parallels, and now let's run this ls-h. It doesn't reveal file sizes here, but that's because I'm using the shell here for demonstration. If you use bash, that presents file sizes in human readable format. And by the way, that's one of the demonstrations of the differences between this shell and bash. If we go back to our Azure portal here and try to run this ls-h, and we'll add long list in here, we'll get such an output. Now, some words about file permissions. I know it's a quite complicated topic, but I'd like to have a brief overview here. Let me get back to my slide. So the system displays file permissions in a specific format. For example, -rw-rw-r, two dashes, then the user, group, and so on. Let me get back to this Outlook here. As you can see, we got all the symbols here, R, W, R, R, and lots of dashes, then 1, then my username, owner name, my group name, file size, which is 0, and then last modification date for the file, and file name. So these are file permissions, and it's specific format for this output with long listing. Let's get back to our slide, and again, to remind you, use step completions for faster navigation, combine flags like ls-lah for details, and one of the useful flags here, cd- will return you to previous directory. So that finishes our file navigation section or lesson. Next up, we'll be talking about file operations. I wanted to put all this information into one lesson, but as I can see, it's quite long, and I'll separate the lessons. And now I'll finish with file navigation, and I'll create separate files or separate lessons for all other sections. So I'll see you there. In this hands-on lesson, we'll take a look at the commands for file operation. Of course, this is not the complete list of these commands, but I'd like to highlight the main, mostly used commands here. So these commands enable efficient management of files and directories in the Linux system. And we'll start with the cp command, which serves as the primary tool for copying files and directories. When using cp, you can copy a single file, multiple files, and entire directory structure. Please note this -r option. It enables recursive copying of directory, while -p option preserves file attributes and permissions. Also, we've got -i option for interactive mode, -v for verbose output, and of course you can read about this command using man pages or --help option. So let's go ahead and switch to our terminal, or better to say Cloud Shell in Azure. So I'll connect to my Cloud Shell here, and when it's launched, I'll create several files for this particular hands-on practice. So let me type ls. As you can see, this directory is an empty one. And by the way, to reveal all the files, I'll remind you that we use ls-a option that'll show us all hidden files. So I'll clear the screen and create some files with touch command. I'll type touch file1 and file2. Oops, sorry. We'll need to rename this one to file1. So now we've got these two files. Let's try using cp command. So I'll type cp. Let's say that we want to copy file2 to file3. So for this, I'll type file2, and then I'll type file3. That'll copy file2 to file3, and now we've got 3 files. Now let's create a directory here. And by the way, to create a directory, we use mkdir command. So I'll type mkdir. We'll be talking about mkdir later on, but for now we'll create a directory. Let's name it dir1, for example. And now, as you can see, we've got dir1 and 3 files. So to copy, let's say, file3 to a directory dir1, we'll use cp file3, and then we'll specify dir1. Now, if we list dir1, it contains file3, right? Of course, we can copy several files with one go. To do this, we'll type cp files starting with file name, and then, for example, we could use an asterisk like this, and we'll specify a directory we want to copy these files to. That'll be dir1. Now, if we list dir1, it contains 3 files. Now, as you remember, dir1 already contained file3, and it seems that it overwritten this file. To be informed that the file is going to be overwritten, we could use cp -I option to inform us that this directory contains already such file. Do we want to override it? As you can see, we've got this message and it informs us about file 1. Okay, let's override it, and file 2 as well. And let's say we don't want to override file 3, so we'll specify no. Now, we can also copy directories. Let's create dir2 with mkdir. I'll type mkdir dir2, and now let's say we want to copy all files in dir1. So I'll use asterisk for all files, and we're copying them to dir2, right? Now, if we ls dir2, it contains 3 files. Now let's say that we want to copy all the contents recursively from dir2 and create a copy of it, which will be dir3. So I'll type cp copy -r recursively dir2, and we'll create a new one which will be dir3, like this. Now if we ls, we'll get this dir3 directory containing all 3 files. Let's ls dir3, and it contains all 3 files. Let me clear the screen. Now, as I've mentioned, we can preserve file attributes with cp-p option. For instance, we could type cp-p file 1, and let's say we'll create file 4. And we can add it to the recursive copy of the directories by using cp-recursive preserve, and then let's say dir3, and let's say we'll name the new directory dest-dir, which will copy all files which dir3 contains, preserving all the attributes. Another useful option is -v. So to use it, we'll type cp-v. That will turn on, so to say, verbose mode, showing what will be copied. So let's say we want to copy recursively all the contents of dest-dir. And by the way, let's preserve all the attributes as well. So that will be cp-rvp. And we'll name a new directory dest-dir2. Hit enter. Now we can see what happens. As you can see, first we've copied the directory and then all 3 files, preserving the attribute. Now let's say that we've modified some file in dest-dir1. So let me open some file. For instance, I'll type, let's see, use nano, and the file will be located in dest-dir1. Oops, we don't need this / because it's a directory located in our working directory, dest-dir1, and the file will be, let's say, file 1. And we don't need this one, of course, because it's just dest-dir. So let's open this file and add some contents here. For example, updated version. Let's save it. Now files in dest-dir and dest-dir2 are different. So if we ls file 1 in dest-dir, and let's use ls-la, here it is. It has been modified at 9 a.m., 9:39. And if we ls file 1 in dest-dir2, that will be different. As you can see, it has been modified at 9:34, and it's empty. Now, if we want to copy files in update mode, let's say that we want to copy only the files that have been updated in the source directory and copy them to the destination directory, we use cp-u mode. That will be update mode. So let's type cp-u, and we'll specify dest-dir all files, and we'll be copying to dest-dir2. Now if we ls-la file 1 in -dir2, that will be an updated version here, 941. So this -u option copies only newer files. Now let's get back to our slide, and the next useful command for file operations is move command, mv. This command is used for moving and renaming files, and it serves to either relocate files to different directories or change their names. Additionally, move can move multiple files at once when provided with wildcards or specific pattern, similarly to cp command. And again, we've got several options for move, such as interactive mode, no override, force move, and verbose output. As a note here, be careful with move. It can override existing files, as well as cp command. Again, let's take a look at move command in action in our Azure shell. I'll clear the screen here, and let's list the contents of our current working directory. Now let's create a new file here with touch command. I'll type touch file 5, and let's say that we want to move this file 5 to directory 1. For this, I'll type this simple command, move file 5, and then specify the destination, which is dir 1. Now, if we ls, we don't find file 5 here because it has been moved to dir 1. If we ls dir 1, we'll find that this file is there. Now, if we want to rename a file, let's say we want to rename file 5 to file 4 in dir 1, we use the same steps. So we'll type mv dir 1, the path to this file, because now we are located one level up than file 5. So we'll type move dir 1 file 5, and we want to rename it to dir 1 file 4, right? Now if we ls dir 1, we'll find that file 5 is gone and it has been renamed to file 4. Now let's say that we want to move multiple files. Let's say that we want to move, I'll type mv file 1 and file 2 to dir 1. So I'll specify dir 1 as our new destination. And now what I've said, this will move these two files without confirmation. And it'll override the files which already were located in dir 1. Now if we ls our current working directory, as you can see, file 1 and file 2 is gone. And if we ls dir 1 directory, we'll get this file 1 and file 2, but these are the new files which have overwritten the original files located in dir 1. So to prevent accidental overwrites, we use -i. So let's rerun the previous command, this one, and let's remove file 2, and we'll move file 3 to dir 1, but we'll use -i option. This will prompt for confirmation if a file named file 3 already exists in dir 1. So let me hit enter here, and as you can see, we've got this prompt, overwrite dir 1 file 3. Yes, now we know that the file has been overwritten, but we confirmed it. Now, of course, we can move all contents of a directory with move command. For this, we'll type, for example, move, let's say dir 3, and we want to move all the contents of dir 3 to dir 4, let's say. And we get this target dir 4 is not a directory. When using move command, you'll need to have this directory already in place. So let me create this directory, dir 4, and rerun the previous command. Now all the contents of dir 3 is gone and moved to dir 4. If we ls dir 3, that will be empty. And if we ls dir 4, that will contain all the files previously located in dir3. Again, we can use -p option to maintain file timestamps and permissions and all the attribute. That will preserve the attribute. And we can use -f option to override write permissions. This -f will forcefully move the files. Again, as best practice here, always verify the destination path exists. Then you can use tab completion to prevent typing errors. Check write permissions on the destination. And consider using -v or verbose mode to see what's being moved. Now let's clear the screen and get back to our slide. We've also got this remove command that is used for removing files. The rm command provides necessary functionality for removing files and directories. This tool permanently deletes all files and with the -r option it removes directories and their contents. And that's the command where you'll use this -i for your safety. So try to use interactive mode when removing files and directories. Because rm is permanent. There is no recycle bin here. Let's run some examples in the Azure shell. I'll list the contents, and let's say that we want to remove all files starting with file name. So for this we'll type rm file and asterisk. Hit enter. No output, it means that an operation has been successfully completed. If we ls, this file 4 is gone. Now if a directory is not empty, this command will give us an error. For example, if we type rm dest dir2, that will say that it cannot remove dest dir2 because it's a directory. In this situation, if we want to remove the dest dir2 with all the contents, we use rm-r recursive and then specify the directory dest dir2. Now command works successfully, and if we ls, dest dir2 is gone. We can also add -f option here that will forcefully and recursively remove all the contents of dest dir2. But we'll run it on dest dir. And by the way, be very cautious with this command because it's quite dangerous. It removes everything and you cannot restore the content. And I'm used to rm-rf like this, recursively forcefully delete. Now this directory is gone and it even didn't ask anything. So please use -i also to double check if you want to remove or not the contents. So let's rerun the previous one, -rfi, let's say that will be dir4. Now we are asked whether we want to remove the content. If we hit yes, that will ask if we want to remove each of the files in this directory. Yes, yes. Let's say that we don't want to remove file 2, we hit no. And now if we want to remove dir4, that will say that it's not empty because we asked not to remove file 2. So if we ls dir4, that will contain only one file, and that is file 2. So when deleting this critical data, consider these safety practices. Use rm-i for interactive prompts, preview files before deletion with ls command, and of course, it's never too late to create a backup copies of important data before deleting it, and avoid using rm-rf for system or important directory. And finally, let's get back to our slide and talk about some directory operations. You already remember this mkdir command. It creates a directory, but what I wanted to mention here is this -p option. It creates a parent directory, and we can create the whole subdirectory structure with this mkdir-p. So let me show you in our shell. Let's say that we are creating a directory and a directory structure for our new project, and we want to create it with one go. For this we use mkdir command with -p option, and let's say we'll name it project. The parent directory will be project. Then, for example, we want to create src subdirectory under project, and then we want to create tmp subdirectory under src. Then we want to create another subdirectory, so I'll type project, let's say doc, and let's say we want to create documents for year 2024. And one more subdirectory, I'll type project, let's say that we want to create test, and one more, let's say current. We hit enter here, and all subdirectories, all substructure is created with one command. So if we ls project, that'll contain 3 subdirectories, and each of these subdirectories also contain subdirectory. And by the way, there is such a command as tree. So if we type tree project, let me cd to this project directory and type tree here. No command found. So you need this command to be installed in your bash to run it. But this command will show you your project structure visually. So please remember this -p option. It's very useful and handy to create the whole subdirectory structure with one go. That'll complete our lesson on file operations. We've covered copy command, move command, rm command, and mkdir command in this lesson. Next up, we'll be talking about file content commands such as cat, more or less, head and tail, and so on. And we'll also need to cover administrative commands, IO operations here within this bash commands overview, and process management commands. So I hope it was informative, and I'd like to thank you for viewing. We continue the series on bash commands overview, and in this lesson we'll be talking about file content commands. Let me switch to the slide on these commands, and we'll start with the cat command, which displays complete file content. Cat command is used very extensively by system administrators, so please remember this command because you'll be using it quite frequently. As you can see, an example of using cat command, you type cat and then the text file you want to display the content of. So let me copy this example and run it in our shell environment. I'll switch to Azure Cloud Shell, connected, because it has been disconnected after being idle for 20 minutes. As a reminder to you that your Cloud Shell is automatically disconnected after being idle for 20 minutes. So let's create a new file. And by the way, I don't use storage here. That's why after each disconnect, I get an empty Cloud Shell working directory. So that's why when I run ls, my working directory is empty. But that's okay for me, because I'm using this Cloud Shell just for demonstration purposes. But please note, if you want to keep all your files, connect a persistent storage to your Cloud Shell. So let's create a text file. I'll type nano, let's say example.txt, and I'll insert the contents I've copied from my slide. To exit, I'll press Ctrl X and I'll press Y to save the contents. Now, if I want to display the contents of this text file, I'll type cat example, hit tab to autocomplete this name, and hit return. As you can see, the whole contents has been copied, has been revealed. Now, the cat command displays the complete contents of a file at once. This command works best with smaller files where you need to see all content simultaneous. The command shows the entire file content in the terminal without pagination. So if the content is quite long, you cannot page down or page up through this content. Now, before we continue to the next command, let me create a longer text file for demonstration purposes, and I'll use a simple one-liner here with bash scripting technique. I'll use for I in, let's say, from 1 to 100. So this file will contain 100 lines, do, echo, and the line will be as follows: line number, and we'll use I variable here, and let's add some more text, for example, some sample text. So that will create 100 lines with line number and this text string. And we'll redirect it to, let's say, long file.txt. And finally, we'll use done keyword. If you don't understand some syntax in this one-liner, that's okay. It's just for demonstration purposes to create a long text file. I'll hit enter here, and let's get back now to our slide. So the next command is more and less command. These commands page through content so that you can view content page by page, and they allow you to control scrolling through large files. And here is the example of using this command. You type less or more and then the file name. So let's go ahead and try to view the content of the file we've just created with bash one-liner. Let me clear the screen here, and I'll type more long file.txt. Oops, seems that our one-liner hasn't worked correctly. Let's review it, and as you can see, maybe you don't see it, but I can see the mistake here. Let me go back to this part, and here we'll need to add, if we want to specify the range between 1 and 100, we'll need to type 2 dots. Now this command, I guess, will work successfully, but we won't append this information to long file.txt. We'll better override the contents of long file.txt. And by the way, let's take a look at how it works with appending. I hit return here, and now if we use more long file.txt, we'll get the first line, which is not correct, as you can see, line number and so on. And then our correct content starting with line 1, line number 1, and so on. So to exit from this pager, we'll press Q. I'll clear the screen, and now I'll get back to this command, and instead of appending, I'll override this file. Now, if we go back to the more pager, hit return, again we get this output, which is not correct. So I guess we need to use append here because we need to append line by line each line. And in this case, if we use override, it overrides only the last line. In this case, let's remove long file.txt and get back to this one-liner and append all the lines here. Now, if I clear the screen and run more long file.txt once more, we'll get the pages through which we can click through or scroll through. And to do this, we just press space. As you can see, when I press space, we get the next page of this long file. And you can do this up to the end of the file, to line number 100. And the same goes for less pager. So you type less long file.txt. And now, as you can see, we don't get this percentage. The output is a bit different, but Nevertheless, we can scroll down the pages like this by pressing space up until the end of the file. And in this pager, when you reach the end of the file, you'll need to press Q to exit. In more, when you reach the end of the file, you exit the file automatically. Here I'll need to press Q and that'll exit this pager. Okay, let's get back to our slide. So for larger files, the more and less commands provide controlled viewing. These commands display content one page at a time. And as I've shown, the less command offers a different functionality and a bit more flexibility. Because in less command, I haven't shown it, but it allows you backward movement through the file. The more command only moves forward through the content. And finally, head and tail commands. When examining specific parts of files, head and tail become useful. The head command shows the beginning of a file, typically the first 10 lines by default. And the tail command displays the end of a file, also defaulting to 10 lines. Both commands accept options to specify the number of lines to display. And for this, they support various options for customization, such as usage of -n with head or tail to specify the number of lines. So as you can see in this example, tail-n2 example.txt will specify that you want to view 2 last lines of this document. Let's run these commands in our shell. So first I'll type head lonefile.txt and that will display first 10 lines. And if we type tail lonefile.txt, that will display 10 last lines. Now, if we want to specify, for example, first 3 lines, we'll type head-n3 lonefile.txt, and the same goes to tail. So I'll replace head with tail, -n3 lonefile.txt, that'll display last 3 lines of this file. Okay, now we are done with file content commands. Let's get back to our roadmap slide on bash commands overview. And the next section is administrative commands in Linux, such as sudo, ps, w. So we'll start with system management commands such as sudo and su. And by the way, you won't find these commands in Azure shell. If we try running sudo here, we'll get an error, no new privileges. And if we try running su, command not found. But still you need to know the information about these commands, because sometimes you could use these commands in your local shell when working with Azure. So let me get to my local shell and show you some examples of using these commands. So the sudo command serves as the primary tool for executing commands with elevated privileges. This command requires proper user authentication and grants temporary administrative access. And when using sudo, the system logs all actions for security tracking. For instance, you want to run some privileged command such as viewing the passwords file. Let's try to view the passwords file with cat. I'll type cat etc passwd, or for instance, I want to modify etc hosts file. For this, I'll need to run the following command: nano etc host and add some contents here. For instance, 192.168.1.123. That'll be nuke 12 PC. Control X, save the file, and as you can see we get an error cannot open file for write and permission denied. That's because we don't have privileges to save the changes to this file if we are not an administrator or the root of this system. Let me exit from this. I'll hit no, not don't say. And now if I add sudo command here, I'll need to specify the root's password here, hit enter, and if I try to save it now, let me add some contents here, like nuke12, hit Ctrl X, try to save, hitting yes, file to write, etc host. This file is saved successfully as a privileged user. The same goes for installing some packages or viewing some system critical files like system log, or when you want to restart or start or stop the services on the system, you'll use sudo for this one-time action. As for su, it provides the possibility to switch to another user account. And if you don't provide any names, that'll switch to root. For example, if you type just su, that'll switch to the root of the system. But if you type like so, su, and then some username, that'll switch to this username. You'll need to provide the name of this user, the password of this user, and then you'll be switched to this user account. If you want to switch to another user and load their environment, you'll type su dash and then the username, like this. And by the way, if you type su just dash without username, that'll switch you to the root environment, root user, and load the root's environment. And when you are done working as this user, you just type exit command to exit from their username, user account. So when using sudo, you'll need to enter your own password. For su, you need the password for the account you are switching to. And please remember that on many systems, root account is disabled by default. As you can see, on my Mac system, using this shell is disabled by default. By the way, you can use also sudo-s or sudo-i for root shell if needed. And the commands looks as so, sudo-i. Now, as you can see, I'm switched to the root. And to exit, I'll type exit. And another command is sudo-s. Again, I'm switched to the root shell. So let me clear the screen and explain the difference between these two commands. When you use sudo-i, it starts a shell with root privileges, and it keeps your current environment variables, and it also keeps your current working directory. And this command uses your user's shell. And as for sudo-i, let me exit from this prompt and type sudo-i. It starts a shell with root privileges, and it also simulates a full root login, as well as changing to the root's home directory. And this command will use root's environment variables as well as root shell. So this was the information, some information on using sudo and su commands, just for your information. But again, please know that you cannot use su and sudo in Azure shell. Now, if we get back to our slides here and continue with process management command. So there are lots of process management commands, but I'd like to note only some of them. Process management commands help monitor and control system operation. And for example, ps command displays current process information, while top command provides real-time system monitoring. These tools help identify resource usage and system performance metric. So let's run some examples in our Azure shell. Let's start with running ps command as it is, and that will reveal the processes currently running in this session. If we use ps-aux, that will show all processes running in this shell. Let me make it a bit smaller like this. And as you can see, we've got several processes running under root user. We've got several processes running under my user. If you want to show process tree or hierarchy, we'll use ps-ef flags, and that'll show the process hierarchy. And if we want to show processes for some specific user, for instance, we want to find the processes for the root user, we'll type ps-u root, and that'll find all the processes for the root user. Or let's use my username, and that'll find the processes for my user. Another useful command for the monitoring of your system for real-time process monitoring is top. So if I type just this command top, that'll launch the system information in real time, where we can monitor real-time process. Now, if you want to sort by CPU usage while in top, press O. So I'll press O here, and then I'll type CPU. If you want to sort by memory usage while in top, press O again and type mem. Now, to quit top, press Q, and that'll finish this real-time monitoring. So these are two basic commands which are good for system monitoring when you only start getting familiar with Linux system. Now, I'll get back to the slide and we continue. So we have only two commands left for this block, W and uname. W will show who is logged in and what they are doing, and uname-a will display system information. So let's run these commands in the shell. I'll clear the screen here and type W. As you can see, it shows 0 users as it is an Azure shell. If we try to run this command in my local shell, let me exit from this root session and type W, that'll reveal that user Shumi is logged for 5 days using console, and one more session is active for this user as well. And if we type uname-a here, that'll show us that it is Mac OS, the kernel version, and so on. And if we type uname in our Azure shell, let me type uname-a, that'll show that it's Linux sandbox host, which is running on Microsoft system. And by the way, if you want to find out the user you're running under, you could type who am I, and that'll reveal your current user. As well as on this local system, if I type who am I, we'll get the current user's name. So that'll finish up the block of administrative commands. I know it wasn't complete enough, but that is for getting started with Linux administration, Linux system administration's command. Next up, we'll be talking about I/O operations and operators within our bash commands overview section. In this lesson, we'll be talking about I/O operations, and bash shell provides powerful input-output operations for data manipulation and command interaction. Linux operates through a set of specialized operators that control data flow. Let's switch to the slide on this topic, and I'll make it larger like so. And we'll start with output redirection. You've already seen how to use output redirection when I've created a long text file. I've used these operators more than. Here it is. So this operator will override existing content. When you send command output to a file, it overrides existing content. And this operator will append to existing content. It adds command output to the end of a file. Let's run some examples in the shell environment. I'll clear the screen here. So let's say that we want to output the content of our current working directory. Let's check it with pwd and let's check the contents of this directory. Let's say that we want to output the contents of this directory in long listing to a file. For this, we'll use this operator to output the result of this command, not to our screen, but to the file. Let's name it, for instance, directory underscore list.txt. So as you can see, we haven't got any output on the screen, but if we cat directory underscore list.txt, we'll get the output in this file. Or for instance, we want to output the result of date command to a file named, let's say, timestamp.txt. Now, as you can see, we haven't got any date command output, but instead we've got this output redirected to timestamp.txt. Again, if we cat timestamp.txt file, we'll get the output or the result of the date command. We could also store, for example, the result of ps command in running-processes.txt file. Let's type the following ps-aux and we'll redirect it to running-processes.txt file. Again, if we cat running-processes.txt file, we'll get the output saved in this file. Now, we could write multiple lines to a file. Again, I'd like to remind you that using this single more than symbol will override the content of the target file. For instance, let's try the following. We'll use echo command and let's add this string to our file, first line, and we'll redirect it to, let's say, multiline.txt file. Now, if we cat the contents of this multiline.txt file, we'll get first line, right? Now, if we rerun the previous command, let's change this first line to second line and output the contents of multiline.txt, we'll get second line in this file, because using this single redirect operator will overwrite an existing content in the target file. And by the way, this redirection is often used to output or save command errors to a file. So if we want to save an error to a file, we could use this redirection. Let's say that we run the following command ls, for instance, some non-existent, hit enter, and we get an error. What if we don't want to get this error on our screen, but instead we want to redirect it to a separate files containing all the errors? So let's try running the following. I'll get back to this command, ls non-exist, but now I'll add to greater than, and then I'll specify the errors.txt file. Hit return. Now we don't get any error, but if we cat the errors.txt file, we'll get this error here. And finally, to discard output completely, you could use the following. You could redirect it to /dev null. It means that any output will be discarded completely. In some cases, you need such a command. In this case, we get an error on our screen because such file doesn't exist. But let's say that we want to run just ls command and redirect it to dev null. We'll get no output, and the result of this ls command is gone or discarded. Now, in case we want to append to a file instead of overriding it, we've got this greater operator that will append to a file. So this greater than operator in Bash adds new data to the end of the file while keeping the existing content intact. For instance, we want to redirect the result of the date command to, let's say, server underscore log.txt file. Now, if we cut this server log.txt file, we'll get the result of the date command. But now we want to append some more information under this line instead of overriding this information. So in this case, we could type the following echo. Let's say we want to add the following line: system backup completed. And now we want to add this information under the date result. So we'll specify server log.txt, and if we cut the contents of server log.txt, we'll get these two lines: the result of the date command and the string we wanted to add. Another example, we could build a list over time. For instance, we want to create a file containing all the users. Let's say that today we want to add Alice to this list, and as we are adding Alice for the first time, we could use single greater than symbol. And let's say we'll name the file team members.txt. Members. Now let's say tomorrow we want to add Bob to this file. We'll find the previous line and change Alice to Bob. And now we'll use append operator to add Bob below Alice. And we'll do the same for instance, Charlie. Now, if we cut the team members.txt file, we'll get all three members here. Each name is added on a new line, preserving the earlier names. Another example, collecting system information commands outputs. For instance, we want to gather the information on the system with ls-l command appended to file inventory.txt file. Then we want to gather disk usage information. We'll type df-h, and again we'll append this to file inventory. And then we'll want to add the following line: echo system info gathered on. Again, we'll append this to our file inventory file, and then we'll run the date command, and we'll append the result of date command to our file inventory list. Now, if we cut this file inventory.txt file, we'll get the following information contained in this file. First, the long listing of our current working directory, then the disk usage information here, then the string we've added system info gathered on, and the date appended below this string. So this double greater than operator is particularly useful for creating log files, building cumulative reports, maintaining historical records, or combining multiple data sources, as well as recording system events over time. The next block in our I/O operations in Bash is on input redirection using this less than symbol. So it takes input from a file instead of keyboard. And here is an example. Let's say that we want to sort some data, but instead of providing this data by typing, we provide it with some file. For instance, in this case, unsorted.txt. So the data will be taken from unsorted.txt file and redirected to the sort command. Let's run some commands in the shell. I'll switch to Azure shell and make it larger like so. Let's list the contents of our current working directory, and let's say that we want to sort team members with the sort command. So I'll type sort and then redirect the contents of team members.txt file to this part, to this sort command. Hit return and that'll sort team members alphabetically. As you can see, Alice, Bob, Charlie. Or for instance, we want to count the words in this file. For this we'll use wc command -l, and again we'll provide the data from teammembers.txt file, and that'll give us 3 lines. Or for instance, we want to process multiple lines of text with tr command, and let's say that we want to process the letters from A to Z, and we want to make all these letters uppercase. So we'll specify uppercase A to uppercase Z, and again we'll provide the source file, which is teammembers.txt. Now Alice, Bob, and Charlie are printed out in uppercase. We could also use both direction, input and output. Let's say that we want to sort some data. For instance, we'll type sort. For instance, we want to sort actually, let's create some unsorted file. I'll type nano unsorted.txt, and I'll insert some data here, some randomly created data, like so, and I'll save this file. Now, if we cat, or better, use more unsorted.txt, we'll get some unsorted data. And now, if we want to sort this file, but we want to redirect the result of this sorted action to another file, we could use the following command: sort, then provide the data from unsorted.txt and output it to sorted.txt file. Now, if we use more to get the contents of sorted.txt file, the contents will be sorted alphabetically, as you can, from A, B, C, and so on. Let me exit from here. Or, for instance, we could use sort-r. That'll reverse alphabetical sort. Again, we'll provide unsorted data here, and the data will be sorted in reversed alphabetical order. Now, another useful technique is to use a pipe. Let me get back to the slide. So, pipe commands sends output of one command as an input to another. As you can see in this example, we've got several commands combined in one one-liner. First, we run ls command, and the result of this command is input into the next one, which is grep, and so on. And the result of this command is output to this command, sort, and finally to unique command. So as you can see, the command pipe flow is as follows. Command 1, the result of command 1 goes to command 2. The result of command 2 goes to the result of command 3. And then we can output it to the output.txt file. Let's run some examples. Let me clear the screen, and let's say that we want to count number of files in directory. For this we'll use ls command to list the files in our directory, and then we use pipe, which will redirect the result of this ls command to the next command, which is wc-l. And as you can see, we get the final result. We've got 12 files in our current working directory. Or for instance, we want to get 5 first files in our working directory. For this, we'll use the following command: ls pipe head-n5. That'll provide us first 5 files in our working directory. We can also find latest 3 files in our working directory. For this, we'll use the following: ls head-n3, but we'll add -t option to our ls command. and it output latest 3 files in our current working directory. Let's explore what's in Cloud Shell by using the bash commands we've learned so far in our previous hands-on lessons. So first, to clear the screen, I'll run clear command. Then use the ls command to list all files and subdirectories in current directory. That'll be our ls command. But wait, what is the current directory? Let's use the pwd command to find out. So I'll type pwd, and it stands for print working directory. It prints the long-form path to what directory you're in. You should see an output like mine. This output means that you're in a directory called your name within a directory called home, at the root of Linux file system. But there doesn't appear to be much in our current directory. Let's use a bash flag to print all hidden files and directories to double check that's correct. I'll type ls-a, a flag A. That output showed us a lot more stuff in the directory than we initially thought. What are all of those files and subdirectories? Some are behind-the-scenes files to make Cloud Shell work. Let's discuss a few of the others. And we'll start with this dot. It refers to your current directory. So dot always refers to your current directory. The next one is this one, dot dot. It refers to your parent directory. Wherever you are, if you print all hidden files and directories, you see dot and dot dot printed. The next one is dot bash history. It's a special bash file where all commands that you enter into the shell are stored. Bash remembers all command history, which, as we see later, is useful. The next one is .bash logout. It's another special bash file that is read and run every time a sign-in shell exists. Linux superusers can modify it to customize your environment. And this one, .bashrc. It's an important bash configuration file that runs whenever you start a new shell. If you decide to open this file to look at it, be careful about making changes, because they can have unintended consequences. Now, when you're entering complicated commands, like for example ls-a and then a long path, for instance .azure/commands/ let me hit tab several times here and we'll get the date, tab several times again. So as you can see, we've got several files here. Let's list all of them with specifying only the year. And if we don't know the year precisely, we'll use question mark as a wildcard for any year following 202. And then we'll need all files. For this we'll use a wildcard, asterisk wildcard for all files, .log. Hit enter, and that'll list all the files. So let me clear the screen, and let's say that you misspelled this previous command like this. You entered this command that has a typo 23 instead of 22. Hit enter and you get an error. Now, rather than entering the whole thing again, to correct your mistake, you can recall previously entered commands by using the up arrow and down arrow. Now try using up arrow key to bring back your incorrect command. Then use the left arrow key to fix it by replacing the final 3 with 2, and then select enter to correct the previously typed command. So I'll hit up arrow and correct this 3 to 2, and we'll see the correct output. Again, don't forget about auto-completion. Like, for example, if you want to type the following command, cat.az, then you hit tab to auto-complete this part of the command. Then you start typing com, hit tab to auto-complete this part of command, you add s here, / again hit tab, and it auto-completes the whole thing for you. So we just used this cat command, but you don't know much about it yet. Practice man command to bring up more information about the cat command. For this you'll type man cat, and you can read about this command all the necessary information. Now, we've talked about changing directories. For this we use cd command, change directory command. And when we enter cd tilde, that'll bring us to our home directory, which is the special home directory in the shell. We can double check by using the pwd command here. So this tilde is another special character in bash that refers to this home directory. And you can always use tilde to refer to the location home, your name, no matter where you are in the shell. So if we change to the .azure / commands directory, now we can pwd to double check it. And again, we use lots of tabs here. Now we can use the special ... syntax to move up one directory. For this we'll type cd ... and that'll bring us to one level up. Again, to double check, we'll type pwd. Now if we type cd tilde, we'll get back to our home directory. pwd to double check it. Now a question for you. A quick question for you. What directory should you switch to if you enter cd ... Is it your home directory, or is it the parent directory, or is it the first alphabetical subdirectory, or you wouldn't switch directory? And the correct answer is the final option, you wouldn't switch directories, because this dot refers to your current directory. Changing directories to your current directory wouldn't change directories at all, right? Now, with that said, let's talk about the processes in our computers. Computers are imperfect. Sooner or later, something will go wrong. That's why you have a job as a sysadmin. It's up to you to troubleshoot and fix system problems. Imagine that a Python application is causing problems. Perhaps it's taken up too much CPU time, or maybe it stopped responding. In either case, you want to stop the application. To identify the process or application, you can use ps and grep. Then to stop it, you can use the kill command. Let's practice this in your virtual machine. Now to reproduce this arrow, let's create some simple application in our Azure Cloud Shell. I'll enter vim, actually let's enter vi, and let's name the application bad.py. Hit return and create some simple scenario. vi is a widely used text editor that Linux inherited from Unix. In any case, any bash user needs to know the basics of vi. So select I here to enter insert mode. In this insert mode, we can start typing the following Python program. For instance, I equals 0, and then while I is equivalent to 0, I'll hit space several times for the indentation. Actually, I'll hit space 4 times, and because Python is indentation sensitive, but never mind this information, and we'll add pass. Now, this program, when executed, runs in an infinite loop. Clearly not something that you want running on your server, right? Now select the escape key to exit insert mode, then type the following command followed by enter. We'll type :wq. As you can see, this wq command appeared at the bottom of my VI editor. So :wq, hit enter, and by the way, W stands for write and Q stands for quit in VI editor commands. Now we'll use the following command to start the program and leave it running in the background. I'll type Python 3 bat.py followed by ampersand to run this process in the background. Hit return. Now this process is running in the background of our Linux server. Be sure to include the ampersand here at the end of the command. Otherwise, you won't return to the bash prompt. In bash, the ampersand runs a command and returns to the command line, even if the command hasn't finished running. It's not obvious yet, but bat.py is now running in the background and stealing CPU cycles from other processes. Let's take a close look at what's happening. To kill a process, you need the process name or process ID. This is a job for ps command. As you remember, we've learned this ps command and we'll type it. As you can see, one of the processes Python 3 process. So use the following command to list all running processes and filter the results to lines that contain Python. For this, we'll use ps-ef. To refresh your memory, a ps-ef command lists all running processes and displays a great deal of information about each. And now to find the processes containing Python in it, we'll use a pipe and then grep for finding the needed information. We'll type Python. Now, from the listing, it appears that bat.py is consuming 99% of the server's CPU time. The kill command kills a running process based on its process ID. And a related command named kill_all kills a process based on the process name. When you call kill, you have to decide what kind of signal to use to kill the process. Use the following command to display a list of signal types. We'll type kill-l and we'll get all the signal types we can use with kill command. But I'll help us. If you were killing a daemon process, one that runs in the background and provides vital services to the operating system, you might want to kill it and immediately restart it. To do that, you could use a sig-up signal. In this example, you want to kill the process without restarting it. Therefore, you want to use the sig-kill signal, which corresponds to the number 9. To the end, grab bat.py's process ID from the ps-ef output. It's in the second column. Let me rerun this command. Here it is. It's 3491. In your case, that process ID could be different. And use the following command to terminate the process. Type kill-9 followed with the process ID. Let me copy it and paste it here. Hit return. Oops, seems that I have copied the wrong process ID. Let me replace it with the right one. Now we've got this process killed. The same command can also be entered as kill-s followed with signal kill and the process ID. But now we won't get such a process. Now if we clear the screen and run ps, there is no Python process anymore. Another common use of ps and kill is to identify and terminate zombie processes, which are child processes left behind the poorly written program. Now, until now, you've been running bash commands on their own. Bash is powerful when combined with other tools. So let's get some practice by using bash to filter output from the Azure CLI. Let's say you want to see an up-to-date list of the virtual machines or VMs, VM sizes available in the West US region of Azure. You could do that with this command: azvm list -sizes -location, let's say West US. And by the way, you can use tab to autocomplete here as well. --output table. Hit return. And as you can see, we got a long list of VM types as an output. Let me make it smaller, like so. And it's quite long, as you can see. We can scroll up for quite a long time. So you should see a long list of VM types as an output, and to narrow down this list to the VM sizes that interest you, you can use grep again to find the needed information. Grep is the Linux's universal pattern matching program. To find the DS sizes popular for use in data science, use the following command. Let me clear the screen, get back our previous command here. I'll make it larger again. And we'll use a pipe here, followed with grep command, and just add ds. Again, hit enter. So these pipes output from the az command to grep, which filters out lines that lack the ds string. So again, I'll make it smaller, like so. And now we get all the sizes containing ds in it. That's still a lot of VMs. You know that ds v2 VMs are more recent series. Let's adjust the grep command to use a more intricate regular expression. And we'll be using asterisk wildcard here. Let me clear the screen, make it larger again, get back to our previous command, and now we'll add ds dot asterisk for all VMs containing the following underscore v2. Hit return, make it smaller again. So this command filters out lines that don't match the regular expression ds dot asterisk underscore v2. So you might recognize some of the characters in this expression from our previous lessons of wildcards, and regular expressions make great use of wildcards. Regular expressions are a topic of another lesson, but come in handy for bash scripting and for this particular example. So using bash with other CLI commands makes the work with Azure a bit easier. And because sysadmin's work never ends, any tool that reduces the workload is welcome. Next up, we'll have a brief knowledge check on all of the commands we've learned so far in these lessons, in these hands-on lessons on bash commands overview, and we've seen some demonstration using bash to easier work with Azure. So I hope it was informative, and I'd like to thank you for viewing. Let's have a quick knowledge check on what we've learned in this module on Linux, on basic Linux commands in Azure and when you use them on local computers. So the first question is the following. Which of the following commands writes a list of processes associated with the username scottgu to a file? Is it cat grep scottgu process.txt? Is it cat greater than grep scottgu pipe processes.txt? Or is it ps.ef pipe grep scottgu redirect to processes.txt file? Press pause here and think about the correct answer. And the correct answer is ps-ef flex pipe grep scott redirect to processes.txt, because ps-ef lists all processes, as you remember. Grep scottgu filters for lines containing this particular username, and greater than redirects output to processes.txt. Let's get down to the next question on directory removal command. So which of the following commands called with the -r option would you use to delete a subdirectory that isn't empty? Is it rm command, rmdir, or destroy command? Again, which of the following commands called with the -r option? So this command should be used with -r option. And the correct answer is of course, rm command. With the -r option, rm recursively removes directories and their contents. rmdir only works on empty directory. So as you remember, if we try to remove a directory which is not empty with rmdir or rm command, we'll get an error. We need to use rm-r option to remove all files recursively contained in this directory. And destroy is not a standard Linux command. The next question is on file concatenation command, on cat command. And by the way, this question, I haven't covered this functionality of cat command because it's not used so often as for viewing the files with cat command. But it's the primary functionality of cat command, and now I'd like to ask you to press pause here and read about this functionality of cat command. And the question is, which of the following commands combines the contents of foo.txt and bar.txt into a new file named foobar.txt? Is it concat foo.txt, bar.txt redirected to foobar.txt? Is it cat with these files and pipe foobar.txt, or cat with these files and redirected to foobar.txt? And the correct answer here is this option, cat foo.txt, bar.txt redirected to foobar.txt file, because cat concatenates these two files into one file, and then we get it redirected to a new file named foobar.txt. And please know that multiple input files can be specified with cat command. The next question is on sudo command. The purpose of sudo command is to, and the options are, run a command with elevated privileges, run a program and leave it running in the background, prevent non-administrative users from deleting system files. And the correct answer here is run a command with elevated privileges. Sudo temporarily elevates the user's privileges. It allows authorized users to execute commands as root or another user. It's commonly used for system administration tasks. And the last command on our knowledge check is on background process command. Which of the following statements is true about the command python 3 app.py followed with ampersand? So again, the command is python 3 app.py ampersand. And the options are as follows. It runs app.py after creating a restore point in the system. It runs app.py and returns immediately to the command prompt, and it runs app.py but only if it's located in the etc directory. And the correct answer is it runs app.py and returns immediately to the command prompt. So the ampersand symbol runs the process in the background, right? And it control returns to the shell immediately. So we get the shell, but the process is still running. But the program continues running independently in the background. Now let's take a quick look what you've successfully completed so far in this module. To wrap up, we've completed shell and bash fundamentals in this module. The bash command line interface serves as a fundamental tool for system interaction and management. The service provides a comprehensive set of commands for the file operations, process management, and text manipulation. When working with bash, understanding this command structure is essential. The system follows a consistent pattern where commands take options and arguments. These components work together to perform specific operations on the system. In this module, we've covered several key commands for daily operations. Initially, commands like ls, which help manage files and directories following this cat and ps, which provide file content viewing and process management capabilities. Additionally, we've covered these I/O operators, which enable powerful data manipulation through input-output redirection and piping, and process management commands, representing a critical aspect of system administration. So Linux operates through commands that help identify and control running processes. These tools help maintain system stability and performance through effective process monitoring and control. Then we've covered some text filtering capabilities which enhance command output management. Linux allows for precise output filtering using tools like grep. These components help extract specific information from command output, making data analysis more efficient. So congratulations, you've covered the basics of Bash tools, which will help ensure effective system management and automation capabilities in your Linux environment. Next up, we'll start a new module, Introduction to PowerShell, where you'll learn about the basics of PowerShell, which is a cross-platform command line shell and scripting language that's built for task automation and configuration management. We'll learn what PowerShell is, what it's used for, and how to use it. So I'll see you there.